Okay, we've got a circle and a smaller circle. We've got point A and D that are on the larger circle. We've got points A and B that are on the smaller circle. The line DB is a tangent, the line AC is a tangent, and they intersect at point E. We're told that E is the midpoint of AC. So if this is the middle of this, then I know that this length AE is equal to this length EC, because they're equal in length if E is the midpoint. So that's crucial really in this question. You'll see here that I've already written down the full proof in a moment just to save some time and make this a shorter video, but I'll just explain it here. Let me just mark in first of all the rectangle, well, the shape that we're trying to prove is a rectangle. I need to prove that ABCD is a rectangle. Now, I've marked on that AE is equal to EC. I also know that EB is the same length as that, and I know that because of circle theorems, and I know that tangents to a circle from an external point are equal in length. We've got an external point here, point E, and this is a tangent to this circle, and this is a tangent to this circle. So I know that these two lengths are equal. And by the same logic, I know that ED, this length here, is also equal to that length AE. This is equal to this, because again, I've got an external point to the larger circle. This is a tangent, this is a tangent, so this length is equal to this length. So that's the next step in my proof. AE equals ED for the same reason. Right, so what we've got here is actual 4 isosceles triangles. This is an isosceles triangle, this is an isosceles triangle, this is an isosceles triangle, and this is an isosceles triangle. So I know that the base angles in an isosceles triangle are equal. So if, for example, I called this angle here, if I called that x, this angle here would be x as well. This angle here would be 180 minus that. And this angle here would be opposite that. So these two angles would be the same, which would mean that these two angles here would have to be the same as those two angles. So that would be x and x there. This isosceles triangle here is identical, is congruent to this isosceles triangle here. This is the same as this. And by the same logic, this isosceles triangle here is going to be identical to this isosceles triangle here. So if I called this angle y and this angle y, then this would be y and that would be y as well. But my point here is that now if we just look at the rectangle, let me mark that on in a different colour. Can you see that the angle DAB is x plus y? And the angle ABC, this angle here, is x plus y. This angle is x plus y. This angle is x plus y. So actually, the 4 angles in this red rectangle are all the same. So if you have all 4 angles in the quadrilateral that are equal, they must all be 90 degrees. Therefore, it must be a right angle. And that's the key thing here.